Okay, thank you very much, Bob, and sorry for that confusion.
Okay.
Before I start, I'd like to acknowledge that this talk is located in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. So what I'm going to do this evening is essentially tell you a couple of stories about plants in Nova Scotia that relate to climate change. And the first story is really about a single species that is really one of the rarest plants in the province and one of the rarest plants in Canada, Eastern Mountain Avens, or Geum peckii, which is essentially limited to Brier Island. And so we're going to look at this species and where it occurs as a microcosm for climate change. I'd like to acknowledge a few people, Barry Taylor and Nick Hill and Jonathan Ferrier, who were co-authors on some of the published work that I'm presenting here. And I'd like to essentially acknowledge one of my mentors and old friends, Sam Vanderkloot, who attempted to teach me taxonomy back in the early 70s. And when I took plant taxonomy from him, the lab exam was 100 herbarium sheets. So he'd given us 400 species names of plants in Nova Scotia, and the lab exam was 100 of them. And for each herbarium sheet, we had to name the family and the genus and the species. And when I didn't have a clue what I was looking at, I put down Canadense for the specific epithet. Anyway, Sam, we became good friends, and he referred to me afterwards as the Canadense kid. Anyway, what am I going to talk about? First of all, climate change in Nova Scotia with, in particular, global warming, and as it relates to Brier Island and Eastern Mountain Avens. And then I'm going to give you a bit of detail in terms of how climate has changed both on Brier and Nova Scotia's whole. And we'll also look at wind, because I suspect many of you have not, well, you might have a preconception in terms of how wind has changed over the last 60 or so years, but I'm going to set you straight. So then I'm going to try and explain why Brier Island has actually changed so much relative to the rest of the province. And the final sort of bit of the presentation is really looking at plant phenology in Nova Scotia. So how has flowering changed in both the fall and the spring, and in particular in the fall of the year? So for those of you that get bored with all of the actual data I'm going to present, I've scattered through this presentation a series of photographs that were part of the latest fall flowering project that we did here. And these are all plants that were in flower starting on the 1st of November 2021 and ended in, well, the project ended in January of 2022. So while the picture and the data in front of you might not relate to one another, at least you can actually see the plant in flower. So this is one of my sort of consolations. So all of the climate data comes from this source, Environment and Natural Resources Canada. And if those of you that haven't used it before, it's a fascinating record of weather and climate across Canada. And there's lots of sites in Nova Scotia where there is relevant data. And for example, if you wanted to look up what was the weather like on your birthday every day for the last 60 or 70 years, you can find it here. Okay, so this is from a paper that Nick and I published a couple of years ago now. And what we're looking at is a map of Nova Scotia with the temperature increments that began in 1998 to 2020. Okay, so we're looking at what was the temperature like here relative to the preceding essentially 40 years. And so all of these values along here in the figure represent how much higher the temperature is in that recent period relative to the preceding period. And it's unfortunate that here's Briar Island, and unfortunately there isn't a huge record that allowed us to do a similar analysis for Briar Island when we published that paper. So I'm just going to sort of, these data emphasize how temperature has changed. I've listed a series of regions on the mainland of Nova Scotia, and what is the average temperature post 98, and the temperature increase from the preceding period. So what you can see is that most of the province of the mainland has increased roughly 1 degree, but Briar Island up here has increased 2 degrees. So it's twice the temperature increase relative to the rest of the province. And that's pretty astounding, because when you look at, consider what, all of our climate negotiations and the UN agreements, we're trying to limit climate change to 1.5 degrees, not 2 degrees. So this would be, on a global scale, this would be considered disastrous. What I've plotted here, the plot on the left, looks at the mean annual temperature of every year in Nova Scotia from 56 to 2022. And what you see on here is that the temperature from the 1960s through to the late 1990s was essentially stable. There was no temperature increase overall in the province over that 40-year period. And then suddenly in 1998, we have this sudden change. And since then, the temperature is now roughly 7.5 degrees, whereas previously it was 6.5 degrees. So this is part of sort of the environment in which we can look at flowering times and phenology in terms of this late period versus the previous period. And over on the right-hand side, I've mapped the data for, or plotted the data for Yarmouth for that period, the orange dots, and then the data that we have for Briar Island. And what's neat here is that in this early period, up to the 1990s, Briar Island was actually colder than Yarmouth, which is essentially 100 kilometers away. And then when we get post 1998, you can see how many years there's a substantial difference in which Briar Island is warmer. And so here down below, I've got sort of the average temperatures of Briar Island from sort of the early and late period, and Yarmouth in the early and late period. So Briar has increased 2 degrees, and Yarmouth, which is very close by, 0.8 of a degree. So there's a real anomaly here. And so that temperature increase on Briar is manifest in a number of ways that I think are important to plants. And one of them is essentially the growing season. So on the left, what I've got is the number of continuous frost-free days from spring to fall. And in this early period, pre-1998, we essentially have 211 days of continuous frost-free period. And this recent period, we now are up to 230 days. So an increase of roughly 20 days of frost-free. And that provides a lot of opportunity for plants to continue growing. And I've compared that to Yarmouth on the right-hand side in that table. And what you see here is that Yarmouth had an increase of 15 days over that same time period. And there's only one other site in Nova Scotia that has, well, there's two other sites, Bridgewater, where the data is not very good, and Keji, which has an increase that's bigger than Briar Island. In addition to that, sort of those continuous frost-free periods, what we can see here is the increase in warming. The number of days on Briar Island, which are greater than 20 degrees or greater than 25 degrees, or even greater than 30 degrees. And I've compared this with two other sites, Grand Manan and Yarmouth, which are, 50 to 100 kilometers away. And what you can see is that early period and the late period, there's been a huge increase in number of days that are warmer in all of these sites. So we went from 26 to 40 days above 20, and 0.8 to 2.2 days for Briar Island. And you can see how this compares with these other sites. So there's no question Briar is getting warmer, and it's getting warmer in the summer, and it's getting warmer in the winter. And so this slide shows, well, Cerastium, which everyone knows, the number of days per year with frost. Okay? And in that early period, we're talking about roughly 110 days of frost per year. And when we get to post-1998, we're down to an average of 90 days. And some years, well, there's one year, an extreme year, where there was only something like 45 days of frost in that year. So we see that there's been warming, and that warming has been year-round. So I told you I was going to talk about the consequences for Geum peckii. And I don't know how many of you know the history of Geum and what's happening with that species on Briar, but, well, first off, the climate has changed dramatically, and has changed both in summer and winter. And that increase in temperature has allowed this phenomenon called shrubification, which some of my botanical colleagues are using. And what's happening is that the shrubs, which tended to be much smaller because of the cooler temperature regimes year-round, are now able to grow much larger, and it's resulting in an overgrowth of this key habitat at the margin of the bog, where Geum particularly likes to grow. And just another bit of background on this species. It is an Arctic alpine plant, and the only other place in the world where it grows is on Mount Washington and the surrounding area in New Hampshire. So it is a high elevation plant, and it seems a bit unusual that it's growing essentially at sea level in Nova Scotia, which is interesting. Okay, so what do we have on Briar that's causing this problem with Geum? In the 1950s, someone decided they wanted to farm the Big Meadow Bog, and they dug a series of ditches through the length of the bog to drain it so that they could grow carrots and some other vegetables. And within a couple of years, it was obvious that they couldn't farm that. I mean, the farm died. But 20 years later, the bog had dried out sufficiently that the herring gulls arrived and they began to nest there. And over the last number of years, we've had 3,000 nesting pairs of herring gulls on Briar Island, mostly in the Big Meadow Bog, which is the prime location for Geum peckii. And that nesting behavior essentially resulted in trampling of the gulls during the nesting season and caused massive nutrient inputs into the system. And both of those are essentially an anathema to Geum, which doesn't like too many nutrients. Okay, and for the last, I don't know, 5-7 years, there's been a group involved in habitat restoration on Briar. And what they've done is they have dammed up these ditches that were present in the bog, and in the hope that this would flood the bog and essentially drive out the gulls because they didn't like getting their bums wet when they were nesting. That was the theory. And on the other hand, it took almost 30 years before the bog dried out enough for the gulls to arrive. And we don't know how long it'll take for the bog to get wet enough to drive the gulls out. So we have these two essential problems here with this species. One is both we have climate change as an issue, and we have habitat restoration, and the gulls, and both of these seem to be essentially intractable right now. And I was at a meeting last week where we spent 3 days where we were discussing the possibility of moving Geum from where it grows on Briar Island to some other place, most likely in Nova Scotia. And we evaluated the feasibility of doing this from both seeds and young seedlings and mature plants. And then we evaluate both, well, the feasibility and then the risks that would occur should we actually do any of that. So it apparently will take a couple of years for this to work its way through the bureaucracy to decide whether or not to continue with restoration to see whether that may have a positive impact, or to actually move towards essentially moving Geum to a habitat, most likely in northern Cape Breton, where the climate is more suitable for it and where it could live for the next, hopefully indefinitely. And now I want to tell you a story about wind and climate change in Nova Scotia. And I came across in the literature this phenomenon called wind stilling. And wind stilling is a phenomenon that was pointed out around the year 2000. And what was being documented was a decrease in average wind velocities across continental areas around the world. And this was initially noted across North America and in Australia. And working with Nick and his interest in forest and how climate might be changing the regime here, I thought, oh, well, let's look at wind in Nova Scotia and see whether or not we can document any change that might be relevant to the plants and potentially Briar Island. So these points represent the averages of the 5 airports in Nova Scotia. So we have Sydney, Greenwood, Halifax, Shearwater, and Sydney. So we're covering essentially, a broad range of area across the province. And what we see is, and this is one of 4 different metrics with which I quantified wind, we can see that wind was actually the highest back in the 50s and 60s. And it gradually decreased over the next 40 years to around the year 2000, okay, and remained stable for up to 10 years. and has since been increasing again. And one of the things I've noticed on the news and so on is people complaining about all these storms and how strong the storms are and how many storms there are. And anyway, I'll show it's just there's no question that winds are getting stronger, but we're only back to the levels that we were in the 80s. And nobody complained then about how strong the winds were and how many storms there were. And as a test, so this dot over here for 2022 is clearly, that's Fiona. You can see that? But this dot in 1976, can anybody come up with what that is? Is that obvious? Who remembers? Anyone? Anyone? This is your test to how good your memories are.
Groundhog Day storm?
This is the Groundhog Day storm. And it's interesting how that's, that storm and Fiona were the only two that really have any significant effect on the general pattern that we see here. Now, Briar, we only have a limited data set for, but it essentially is greater than the major airports in the province. And so it looks like one of the windiest places that we have in Nova Scotia. So there's one metric, annual wind maximum. Okay, this is so here what I've done is quantified the number of storm days. And I've defined a storm day as a day where the wind is 75 kilometers per hour or greater. And this is on the Beaufort scale, this is a strong gale, and it has the capacity to break branches on trees. So every day that a wind gust occurred at that, I term a storm day. So what we see for our 5 airports in Nova Scotia is, again, essentially the same pattern as we saw for the annual maximum wind gust. It was much higher. We had more storms, more storm days in the late 50s and 60s. It decreased precipitously to around the year 2000, was stable for a few years, and then began increasing again. And again, Briar Island is stormier than all of those airports, and essentially a set of points that would be above all those shown here for those airports. So we can see that Briar is currently one of the, it has stronger winds and it has more storm days than most of the rest of the province. And that clearly that phenomenon of strong winds really does affect coastal vegetation in the sense of it. If you're familiar with the term crumholtz or tuckamore, it's difficult for trees and shrubs to grow close to the water, close to the ocean. And anyway, so that's storm days. And so now I'm going to just sort of ask the question, why has the climate changed so dramatically on Briar? And is there any long-term hope for recovery? And sorry, and you notice I have a question mark there. This might actually be philosophy and not the lepidium, but anyway. So why has it changed so much on Briar? And is it possible that this might be reversed at some point in the future? Well, perhaps it can be. So it's possible, I think, and I'm going to present the oceanographic argument that would suggest that there are changes that might occur which would allow Briar Island to revert to the mean of Nova Scotia. So that's what I'm suggesting as a possibility. Okay, so this sort of summarizes where we are. We know that temperature rise on Briar is twice that of the rest of Nova Scotia, and it seems to be above and beyond temperature rise in the rest of Atlantic Canada. So I have similar figures for PEI and New Brunswick and the island of Newfoundland. And all of those other places have essentially a maximum of 1 degree temperature rise over the last 60 years. So that raises the possibility that there's something special happening that's influencing Briar Island. And if that explains the temperature, well, I'm hoping that I'm going to argue that there is something happening in that area that is causing Briar to be so warm relative to the rest of the province. And I'm also hoping to explain this sudden jump in temperature that occurred throughout Eastern Canada, and particularly in Nova Scotia, beginning in 1998. And I haven't seen this anywhere in the literature. So if we look at that globe, okay, that map, and what we see in essentially the Gulf of Maine and off the shore of Nova Scotia, okay, the Atlantic coast of Nova Scotia, you see that red. And that red represents an ocean hotspot. And that hotspot is warming at a rate faster than 99.9% of the global ocean. I mean, it's incredible. And so we can ask the question, why? Okay, what is it that's happening? And we already know that ocean hotspots in the marine realm have caused kelp disappearance in St. Margaret's Bay. I think the spread of this seaweed Fucus serratus is largely due to temperature warming along the Atlantic coast. So this slide from Pershing et al., or this image, you can see that very steep increase occurring in the Bay of Fundy. And after a slight lag, I mean, I'm saying my argument is that the real change happened in the late 90s, but I can see a lag that took place before that warming really was initiated there. So here's Fucus serratus, for those of you that don't know it. It's one of the most easily recognized seaweeds. The margin of that frond has a serrated edge, hence Fucus, hence the specific epithet serratus. And I was talking to Mary earlier about having this as a potential project for iNaturalist. Okay, so this graph is from the Gulf of Maine Research Center, and it's looking at temperature rise in the Gulf of Maine versus essentially the global average for temperature warming. So the green is what's happening globally, and that the blue is what's happening in the Gulf of Maine in that hotspot. And you can see it's warming 3 times faster than the global average. And that's an amazing change of that's occurring there. So now we get to the potential explanation for what happened in 1998 and what happened, why are we in this warm period as a consequence of that? And this is, my explanation has to do with Atlantic multi-decadal oscillation. And this is a phenomenon that was first recognized probably in the early 2000s. And what it's showing are oscillations. So here we have, I think these are monthly spikes in which the temperature in the North Atlantic Ocean is either elevated, okay, in red, or lower than normal, which is in the blue. And there seems to be this multi-decadal oscillation occurs over a 55 to 80-year period. So that's shown by sort of the lower figure here, which is a summary of the above sort of peaks and valleys. And so what's interesting is that this period, this cool period down here in blue from essentially the early 60s up until the late 90s is equivalent to this period over here where the temperature in Nova Scotia was essentially stable and roughly 6.5 degrees. And now we're into this period starting in the late 90s where the Atlantic Ocean went into this warm phase, and now we have this shown in these peaks of temperature starting in 1998. So the Atlantic multi-decadal oscillation. And it's, yeah, various oceanographers have looked at this. Some people say it's an artifact, and other people say it's probably the most significant sort of cyclical change that's affecting global climate. So anyway, I like the pattern is interesting and it's consistent with the temperature change that we see here. And when those hotspots arose in the Gulf of Maine and along the Atlantic coast of the province. So this is where I attempt to put it all together in terms of how that change in the multi-decadal oscillation from that cold period into the warm period may be was the trigger for the temperature change we're seeing in Nova Scotia and the Gulf of Maine. So as part of this change from that negative period into the warm period in that oscillation, the Gulf Stream moves slightly north. And what it means is that the Gulf Stream is moving closer to Nova Scotia, and it seems to be restricting, and this is my interpretation now as a hypothesis, it's restricting that Labrador current so that there's less cold water coming along the coast of Nova Scotia and then into the Gulf of Maine. So there's my model for what's happened here. Now, that oscillation was longer periods. And we've known that from the Pacific Ocean, we have so-called ENSO, or El Nino Southern Oscillation, where every year or two or every 3 or 4 years, there's a change in major wind patterns across the tropical Pacific Ocean. And during those El Nino periods, the wind is essentially blowing from west to east and building up warm water on the coast of South America. And during those blue periods, the wind is essentially from east to west. So it's blowing those surface waters away from the continent of South America and allowing upwelling to occur. And that's when the very strong fisheries take place. And much of the weather systems that we see across North America can be related to what's happening with the conversion of the relationship between El Nino and La Nina. And so I'd like to point out a couple of things here. So both the table and the figure come from NOAA. What is it? The National Oceanographic and Atmospheric Administration in the US. So these are from their official website. And you can see the periods of red and blue shown here and shown in the table. And I'm not asking you to memorize the table, but what we can see is that there was a major shift in 1998, okay, into a period of La Nina. So this was a very long period of La Nina, and that corresponds to when that temperature jump occurred in Nova Scotia. So there's one, I would say, correlation. Okay? And if we look at 2011-12, this was another warm period in Nova Scotia. If we look at the most recent period, beginning in 2020, this has been among the warmest years in the province. And on the contrary, if we look at the periods of El Nino, going back to 1997, that was a very cold year in Nova Scotia. This 2015 was another very cold period in Nova Scotia. So it is interesting that it seemed these periods of El Nino and La Nina seem to correlate with warm and cold years in Nova Scotia. And this sort of overlays the general phenomenon of the North Atlantic oscillation. So this slide just sort of summarizes what I've been saying. So we had a change in the Atlantic multi-decadal oscillation to a positive phase at the end of the 90s. That resulted in a repositioning of the Gulf Stream closer to the continental shelf and a restriction of the Labrador Current and the Nova Scotia Current, so that we essentially had warm water near the surface along coasts of Nova Scotia well into the fall as a result of this. And this was also a period of very low wind when there was much less mixing. So I think that's part of the reason why we got that large bump in air temperature starting in the late 90s. And as a consequence, we developed ocean hotspots off the Atlantic coast and in the Gulf of Maine. And we have shorter term influences associated with periods of La Nina and yeah. So we can look ahead with that model and we can ask the question, will the climate continue to warm relative to regional increases? And if what I've suggested is correct as a hypothesis, when that AMO reverses and goes into the next cool period, I would suggest that we would see a cooling of temperatures both along the Atlantic coast and on Briar Island. And so the question is, will that sort of relatively minor change be overwhelmed by what are almost certainly ongoing regional temperature increases as a result of global climate change? And so, it's possible that Briar might get some relief 10 years from now or 20 years from now. And just to comment on wind, if this continues to increase, will this impact the wetlands of Briar Island in terms of tree and shrub communities? So it's possible that increasing wind may help limit that shrubification of the island and the way in which those shrubs are out competing the Geum in its prime community. Now I'm going to get into sort of how the flora is essentially changing overall in terms of its phenology. And I suspect that many of you have seen this in your own lifetime. I mean, you've been out, you're out in the field, you're identifying plants all the time. And I suspect you've probably have, in your field books and so on, probably have as good a record as I do in these studies that were conducted in, 2001, 2006, 2012, and 2021. And I'm not sure if the data I'm going to show you is, if those are the only years in which these phenological changes occurred, or if those just happen to be the years in which I was able and had the time to do the field work. So we're going to talk about extended flowering based on warmer fall temperatures and advanced flowering based on early spring temperatures. There's 3 studies in 2001 when we had 92 species flowering after November 1, 2006 when we had 135 species flowering after November 1, and 2021 when we had 115 species flowering. And I'd be fascinated to know how this, how your personal observations essentially are consistent with my observations. The first study it was done in 2001 and we published it a couple of years later. So we found 92 species of herbaceous plants in 62 genera collected between November 1 and the 15th of January. And it was interesting that when you go back to the Flora of Nova Scotia, that only 6 of those had actually been listed as flowering in November. And I mean, I was amazed to be able to go out in the middle of December and find 29 different species in flower. Okay. Now, to verify whether this was, people had found these plants before, but just never bothered to comment on them, I went through, for every one of these 92 species, I went through the herbaria at Acadia and the Provincial Museum and in Truro and looked at essentially every sheet of all of those species to determine, had other people actually made collections that were relevant to this. And the basic observation here is that the average extended flowering time for these species was 45 days. All of these were done in Antigonish County, and you can see I collected along the South River, and a lot of the sites were in and around Antigonish, and one site up here at the provincial park at Arisay. So we could sort of ask the question were in that year when we did that study, was the temperature actually warmer than normal? And so we could compare sort of the mean temperature in Antigonish and Collegeville, which is down near Loch Arbor, which is the longest running weather station in the province, and then the so-called climate normal. That fall really was a warm fall. And there's no question that for each month, I mean, there were delayed frosts. So in Antigonish, there were no frosts in Antigonish in September, only 4 in October, and 17 in November, in terms of when the temperature dipped below freezing. And by the time you get to the middle of December, there were actually snowfalls, and the snow melted, and the plants came back. And this shows the range of additional flowering days amongst those 92 species. So as I said, the largest column here is roughly 45 days, and that happened to be the average. But there were only a couple of species for which we didn't have the most extreme flowering event. And you can see up at the top end that some were flowering up to 120 days later than any record in the provincial herbaria. So I was, pretty impressed by these data that at this time, I mean, in that year, that we had very extensive flowering well after November 1. But at that time, we hadn't really looked at climate change. And what we suggested here was that, well, this is what flowering would look like if indeed climate change had occurred, as opposed to, yes, this is climate change. Oh, they were disappearing off the bottom. And so one of the assumptions we made was that if we found a plant flowering in December, okay, that it could have been flowering in early November, but we just didn't find it. And so here we have this really nice decline over each of those columns represent 10-day periods. So in early, middle, and late November, and then early and middle December. And you can see how essentially the number of species was a straight decline. One of the other things that was neat about this was that most of those species that we found were non-native plants. So the bulk of the plants, at least 60 of those species, okay, were introduced, essentially mostly ruderal species occurring on soil mounds and roadsides and ditches and highly disturbed habitats. And these native species mostly occurred in non-disturbed habitats. And you can see how there's far fewer of them. And the native species, while there are more overall in the province, are significantly fewer than the introduced ones. We quantified the proportion of these species relative to their occurrence in the different families in Nova Scotia. And again, I'm afraid it's cut off, but this first column, or this first pair of columns is the sunflower family. And so you can see that we found more species in the Asteraceae as a proportion of ours than there were in the flora as a whole. And similarly, family 2 is the Brassicaceae, where we found more plants in flower relative to their proportion in the flora of Nova Scotia. And so those two were overrepresented. And family 7 over here is the Rosaceae, where we found many fewer species, as in the black column, relative to the proportion of species in the flora as a whole. So that was the 2001 study. And then we repeated this in 2006, okay? And here we found all of these species flowering well into January. I mean, this blew us away. I go out and look around, building sites and so on, and suddenly you see these blooms. Now, the picture of this aster on the left, they weren't all gorgeous, pristine flowers, and many of them did show considerable weathering. But the fact that you were able to see, pigmented petals, and in many cases the flowers look almost normal. And so here we have, this group of 21 species, or sorry, 23 species from 19 sites that were flowering in January. So I'm hoping people can comment on how many species you guys are finding in January. There was one year when, in the middle of March, I suddenly started seeing plants in flower, and that's remarkably early. And I think it was, I was at an event on St. Patrick's Day, and we went for a short walk. I think it was Nick was there with me, and we went through for a walk in his backyard through an apple orchard, and it was a beautiful day, and there were a number of plants in flower. And so when I got back to Antigonish, I said, right, I'm going to see how many plants that we could find that were flowering in March and April. There's no question that the weather was incredibly warm that spring. So if we look at, so for Kentville in March, for example, we have an average temperature of -9, and that's the historical record. And in 2012, yeah, we have almost 8 degrees. And in April, we have 5 degrees as sort of the daily average versus almost 13 degrees. And this is sort of the same sort of change or was occurring in Tracadie, which is the weather station closest to Antigonish. So there's no question that February, March, and April were warmer by quite a few degrees, okay? And that seemed to be inducing plants to come into flower. And what we can see here is over on the, this is a repeat of sort of this temperature change in Nova Scotia. You can see that we're now over here at 2011 and 12, where the mean annual temperature was over 8 degrees in the province. So there's no question this was an extremely warm period, warm year in the province. And the data in that table show that that started really early in the year. So here's a list of all the species that we actually found flowering in March and April. And virtually all of these were found to be flowering earlier than the earliest specimens in both the Acadia Herbarium and at the Agricultural College in Truro. And there's only a couple of species here where we didn't find the earliest flowering records for these species. So that Amelanchier and the dandelion down at the bottom. And and this viola, this yellow viola. So in an extreme year, the plants certainly do respond to a very warm spring. Okay, so I'm not sure if I've used up all my time, but here are some sort of general conclusions in terms of temperature change and its impact on the province. We know that warming of an average of 1 degree has occurred across Nova Scotia beginning in 1998 and essentially remaining stable since then. And that's been associated with reductions in days with frost over the winter and days with frost in the fall, and a major increase in frost-free periods. So we've had this, up to 2 weeks, 3 weeks, depending on where you are in the province, increase in the potential growing season. And point 3 here, overall, wind is not correlated with temperature. And we've done the math on this and the linear regressions. And essentially, if you try and relate maximum annual temperature with maximum annual wind gust or any of the other wind metrics, the relationship is actually negative and significantly negative and not positive. We can also say that plants respond to warmer falls and springs by flowering. And this is most evident among alien species. And this is sort of another bit of conjecture here, but even in Antigonish, I have actually seen some plants flowering in February. And I think the 2 species that did that a few years ago were Johnny Jump Up, Viola tricolor, and a shepherd's purse. And so if the climate does continue to warm here, it wouldn't surprise me that we would actually be able to go out and look for wildflowers year-round in Nova Scotia. And so the Wild Flora Society would have a lot more opportunities for field trips. So I think a final slide here. Okay, so I'm going to open up to questions. And I think I have one more slide just to emphasize something that has already come up at this meeting. So, right, so this is the campaign to save West Mabou Beach Provincial Park from the ravages of this proposed golf course. Anyway, so I'm going to stop there. I'm sorry if I've spoken too long. And if you have the patience for questions, I'd be happy to entertain them.
Hi, David. Thank you so much for that.
Well, you're most welcome.
I've always taken pictures of wild flora, and just lately, Beth Sheila Kent encouraged me to start posting them on iNaturalist.
Yes.
And I do look for samples of flowering plants at very odd times of year. A lot of bunchberries this year in December on our property.
Well, and where is that?
It's in Parsboro,
Yes.
in the Geopark, the Cliffs of Fundy area.
Wow.
And I'm very interested in documenting. Are you able to get things from iNaturalist, and do you follow that site?
I'm embarrassed to say, well, not embarrassed. We do. My wife.
I'm listening, David.
Yeah. we do use iNaturalist, and as I say, my plant identification in the field. I mean, sometimes things, you know, I see a plant and oh, I know what that is, but oftentimes we'll see a flower and we will go to iNaturalist and take a picture and hope that it comes up with an ID. And if I collect it and make a herbarium sheet, then we've got sort of a permanent record of that, and we sort of make sure we key it out to verify the identification.
I see.
No, iNaturalist has become an amazing tool.
Thank you.
And I would say both for naturalists and professional botanists.
Very good. Thank you.
You're welcome.
I have a question. You mentioned that you compared the flowering dates with what there was in the various herbaria.
Yes.
Is there? I've seen a fair number of plants late in the year, and they tend to be, well, not quite as good looking, if I can use that term, as those that flower in their more expected time. Is there a possibility that would have impacted the collectors to say, okay, oh well, this is not a very beautiful specimen, so let's not collect it? Have you taken that into consideration?
Yes, that is an obvious problem with how we conducted the research. On the other hand, the herbarium at Acadia and in Truro has many, many collections that are student collections who have to go out and collect, you know, X number of species,
Yes,
mount them, and they get put into the herbarium. And so there's something that sort of counters that trend that you say. And I don't know how to get around that other than by repeating the study, you know, over multiple years and going to iNaturalist, where I think many of these records may be found.
good, thank you.
I'm curious, there's a teacher that had his kids noting flowering times of plants quite a long time ago. Other people here probably know the details of this better, but it was there was a thing in the news a couple of years ago about these records, these meticulous records that were kept over time. And I'm just curious if you've tied any of that in with your observations.
Well, it's interesting that when we published the spring flowering study, there was a mathematician from the States who was on sabbatical I think in Truro at Dalhousie. And he actually did a climate modeling. And he started with the Mackay records from essentially 1900s. I mean, it was amazing what Mackay did then.
Yeah.
And he used the records that we published in our early spring flowering thing. And it actually was absolutely consistent with essentially the temperature change that he could model using this, I would say, very elaborate mathematical treatment.
That's great.
So he cited our paper positively.
That's nice. Joan?
Yeah, I've been really anxious to speak about Dr. Mackay. He was the superintendent of schools for Nova Scotia from 1900. And during that period, he had every grade 5 teacher in the province do a curriculum study on phenology.
Yeah.
And I thought it was such a wonderful thing because my mother and her siblings talked about going out in the field when they were in grade 5 and collecting and noting plants.
Yeah.
And it was part of their required curriculum. Think of all those students across Nova Scotia doing it.
Wow.
And then the department, for reasons unknown, political, no doubt, it stopped and nothing happened with it. And that seems such a shame. Then there was a revival. There was a lot of pressure from teachers who were interested in science and natural science. And there was a revival through the Nova Scotia Museum of Natural History.
Yes.
And it was a Thousand Eyes project. But I don't know what came of it. It didn't seem to take off because it wasn't mandated.
Yeah. We can see Mary. Mary, say something
Yes, please.
so that we can see the screen.
Yeah, the original Mackay study is in a spreadsheet format, and the museum does have a copy of it. So if anyone wants a
Wonderful.
research project, it's there. The same thing with the Thousand Eyes, that's in a spreadsheet. I'm supposed to be working on getting that formatted correctly. But we tried to encourage a few years ago, get people to do something similar on iNaturalist and to get it together, and really hoping as part of the City Nature Challenge to reach out to schools and to say, hey, kids, you know, get outdoors, connect with nature, start observing a few things and teach them early. And so that's the thing. But this is a guide, and the museum has boxes and boxes of these, which are really just telling people to look and report the first time they see something flowering. So,
yeah. So I must say, I despair of, well, the knowledge that high school students and university students have of our native flora. I can take students out in the field and they wouldn't recognize a strawberry plant if they tripped over it. You know, they can barely recognize what is a maple tree. It just, I don't know what's going to come of this. You know. Anyway.
David, we had a question about your work. So you talked a lot about wind speed, but you didn't really touch on direction. And so we were wondering if there was any changes in direction, because direction would have an impact on the upwelling and those currents.
Yes. So it seems to be quite stable right now, in the sense that overall I haven't seen. I mean, my data can't show any changes in air temperature across Nova Scotia as an average over the last 22 years. But it has been, the recent annual air temperatures are like 8.2, maybe 8.3, 8.1. And if we had another 2 years of those temperatures, we could say that there was a significant change over the last 25 years. So if it continues to be that warm, if it continues to be that warm, we can show a significant change. Does that answer the question?
Not really. We were curious about if there'd been a change in the wind direction, not the
Wind
temperature,
direction.
but the
Okay,
direction.
sorry, wind direction. This is much harder, and the answer is No. I spent a lot of time trying to figure out how to quantify wind or the direction from which these storm winds were coming. And there is a seasonal difference between essentially summer and winter, but I have been unable to tweak out a change in direction over the last 65 years.
Great, thank you.
I can see with a cyclone type of storm, really depending on its track, the winds are going to be all over the place. So it would be hard to get an overall sense from that, you know.
Exactly. Yep.
I've got a comment on a couple of things about Briar. Well, one thing about Briar Island, anyway. First of them, well, has to do with the gulls. Gulls are long-lived. That means that any change you make in the bog is going to be reflected in a very slow change in the gull populations. You know, if a gull lives for 20 or 30 years, and as fixed nesting site in that bog, even though it's getting wetter, it doesn't like its bum getting wet, it's probably still going to go back and attempt to nest, and they seem to be doing that. But I've been an eye on recruitment for the past few years since the bog restoration took place, and it's pretty clear to me, although I can't quantify it and we really need a survey, that the number of young is decreasing very rapidly. And you can tell that in two ways. First of all, I try to count them on the shores.
Yes.
When they look at that, and they do accumulate their numbers, and the numbers seem to be going down there. And the other thing is the number of first immature herring gull pizzas that are on the road. In other words, the number that gets run over by cars. And that has definitely gone down. There aren't nearly as many gulls being hit by cars. And that is because there aren't so many immature gulls, that is less than 1 year old, stumbling around on the roads and being hit by the tourists. The other thing I would like to say about your model of the oceanography, which shows movements of water like the Labrador Current and the Gulf Stream, is a bit because the Gulf Stream, if we take an example, is actually a series of vortices rather than a stream. It's not a river in the ocean, as Maury called it 150 or so years ago. A series of vortices, turbulent patches, in other words, some of which move inshore and some of which do not. And obviously a lot have been moving inshore recently because we're seeing tropical fish, or at least warm water fish, inshore, including seahorses and a variety of other species. But in any case, what we're looking at is a lot more complicated than a ribbon of water moving north or south in the case of the Labrador Current or Gulf Stream of the Labrador Current. And how one quantifies turbulence effects, how much water comes onto the Scotian shelf from the Gulf Stream, I do not know. But probably somebody at BIO's got a better idea than I, who basically a biological oceanographer in the background. Anyway, that's my little bit, Dave, and I very much enjoyed the talk, and also the many talks we've had, or at least the number of talks we've had while on the island about some of these things as well.
Yeah, no, and that's my sort of fear in that sort of hypothesis that I presented, that I've clearly grossly oversimplified the oceanographic factors that are relevant here. But I'm just seeing this pattern, and the pattern makes sense to me. And, you know, it's, I would be curious what happens when that AMO actually reverses itself. I mean, that to me would be, you know, a real event that would, if I'm correct, decrease the temperature in Nova Scotia in terms of air.
Yes, there should be a short-term model of that, and that would be the North Atlantic oscillation changes, which are in a much shorter time. And I think one would be able to monitor that and get something not really sure. Another point I just came up to mind is that if it weren't so windy on Briar, I can vouch for the fact it's windy. There would be, and it would be even as now.
Yeah, although I was there in December a couple of years ago in a blizzard collecting seaweed, and I almost froze to death out of a big pond. Oh,
Yeah, I referred you a couple of weeks ago. I was not there, but our son was, and it was, close to -20 and blowing a gale, and not fun. One would be hard pressed to find warming at that time.
anyway, so I hope to get back at some time. Yeah. Anyway, so Nick, I'm relying on Nick Hill to sort of drag me back into the work that he's doing on Briar.
And I noticed on your graph, it seemed to me that this current oscillation is the temperature's higher than the previous ones. And so it makes me wonder, and I guess we're going to have to wait 20 years or more to see whether the downswing is going to be as deep or whether it'll be shallower.
Yeah, no, the range of that oscillation is a total of 0.4 degrees. And yeah, I mean, that's what we know about it.
Okay,
I had a question.
go
Go
ahead.
ahead.
As a plant person, as opposed to a scientist, I was wondering about the ethics of trying to establish a population of Geum on Cape Breton Island, which seems to have a better climate considering the warming on Briar.
Absolutely. And it is interesting that, I don't know, about 25 years ago, I was at a meeting of the Canadian Botanical Association, and they wrote a letter to a government agency saying that that should be done only as a last resort. And there's no question that the provincial government is aware of that in terms of Department of Natural Resources, and that would be done only if there was obvious extirpation, was what was going to happen that was imminent. And nobody, certainly none of the professionals are champing at the bit to actually move Geum around until it's clear that it won't survive long-term on Briar. But we do have an obligation as a country to maintain this rare species, that this is the only place in Canada it occurs, and it only occurs in one other place in the world. So there is an obligation here to maintain this species.
I think the ethics of this is also fascinating, because if you think about a lot of these plants that are now moving north or colonizing these areas as climate change happens are introduced species. As you mentioned, the ones that are flowering, very few of them are native. And I'm assuming that's because they evolved out of Europe, where the Gulf Stream warmed the winters anyway. But it means that if we are willing to accept the fact that these habitats and the flora that live in them are going to be changing over time, then it becomes a question of which changes do we want to encourage and which ones do we want to discourage, or do we want to be totally hands off? And I mean, it's a huge question I don't know the answer to.
Well, I think we've sort of backed ourselves up against a wall here, in that we've destroyed so much of the intervening habitats, so that it's very difficult for many of these species to undergo sort of natural colonization of, where a habitat might be 50, 100, 200 kilometers away.
Yeah.
And it's a dilemma that we're going to be facing increasingly in the future. So thank you for that point.
Anybody else? Well, I think it's time to wrap things up. And I really want to thank David for a really fascinating and educational talk. I'm going to actually go back and look at some of those slides again, I think. It was really good. And in fact, I will be posting this to our website, just so people know if anybody didn't catch all of it or people that missed this evening's talk, you will be able to see it on our website. And I really want to thank David for a very thorough and comprehensive discussion. A lot of things to think about there. I really appreciate that.
Okay, you're welcome. Anyway, well, good night, everyone, and I hope that I can join you on some of these field trips you're planning. They're fascinating.
Yeah, that'd be wonderful. Please stay in touch on that. And I'd love to have you along. I'm sure it would be fascinating to hear what you're seeing while we're there.
Okay.
Okay.
Okay. Good night, everyone.
Okay. Good night.
Right.